All right, good afternoon. Thanks for coming out to learn a little bit about TypeScript. I think this will be a fun topic. It's something I certainly have found fascinating as I've had a chance to use it and explore it and preparing to teach it. So hopefully you'll learn something here, learn a little bit, or learn a few additional techniques that you can use in your TypeScript to communicate your intent more clearly. One of the interesting things about all programming languages is that they are all just communication tools. Typically, the communication is between the developer and the compiler. But there's also a very important part of the communication that is between one developer and the rest of the developers, or between part of the team and another part of the team, or the ever popular myself as I'm writing the code today and myself as I'm trying to maintain this code 6 months from now. Because future self is pretty angry at my current self on a pretty regular basis. My wife and I have been here all week. We are from Indiana, and it's been a lot of fun getting to spend some time in Australia. One of the things that we've enjoyed are those subtle language differences between the American English dialect and the Australian English dialect. One of them that caught my eye the other day, and we actually got a picture of it, is these signs on the escalators that say, "way up." And that's interesting to us because in the United States, if you would have a similar marking, it would probably simply say, up. You know, I don't know why that's funny or different to me. The same thing with way out or way down. Those are not ever things you would see on signs in the United States. But honestly, this is more descriptive and more accurate. If we were in the States, it would probably just say up, which is true, but that doesn't really tell you too much about it. The fact that we can here just say way up actually tells you a little bit more. And that's very similar to the relationship between JavaScript and TypeScript. Both languages have the same capabilities. It's just that TypeScript can be more descriptive of what's going on. And the fact that TypeScript actually compiles down to JavaScript should be a pretty good indication that there's not a lot of additional functionality you get. It's really about how much information are you communicating in your code. So just to level set before we get into the presentation, this is not going to be an intro to TypeScript talk. I'm going to assume that you guys have some experience with TypeScript because I want to move on to some of the things that I find a little more entertaining. And so I'm not going to go into some of the fundamentals of TypeScript, like how you add types to variables or parameters, or how you create classes, how you use type definition files, or configuring the build and all those things. So if you want more information on that, I'm sure you can find it, but you won't find it in here this hour. So I'm curious, just show of hands, how many of you are currently using TypeScript for some of your work? Okay, that's fantastic. So I think it's safe to say that you guys don't need this information. I'm not going to try and cover it. You will obviously see some examples of this. A lot of these things are the things that make TypeScript so incredibly powerful and so incredibly useful on larger projects. But different topic for a different day. So one of the key features of TypeScript is the type system. I mean, they're tricky. They hit it right in the first 4 characters of the language name. And so we're going to do a real quick review on Datatypes, which I know is kind of like a intro to computer science type of topic, but we're going to buzz through it real quick just so that we have all the same terminology. So just as a refresher, a data type defines the collection of data values and a predefined set of operations on those values. So we're talking about some kind of object and what it can know and what it can do. If we were going to draw this up on a whiteboard, if we're just going to diagram out what it would be, we would usually use some kind of pseudo UML that looks kind of like this, where we'd have some kind of type name, we would have the data and the operations, or as we sometimes will say, the type and its state and its behavior. And we have a type, then the the members of the type can also have types on them. So we can have a type, and the members also have, you could have type A and type B. And that could be numbers and strings and whatever else. So to have a slightly more concrete example of a data type, we could have a type that represents a person, and it might have state to represent the first name and the last name. Those would probably be represented as strings. And there might be some kind of behavior here to get the greeting for that person that is a function that also returns a string. So with that being said, I mean, this is kind of like the classic definition of data types that's fairly universal across all programming languages. And so now we'll dive into a little bit more about specifically what TypeScript can do. One of the really useful things that TypeScript adds over JavaScript is the use of generics. Now, if you're familiar with C#, this implementation will probably look fairly familiar to you. How many of you guys have some background as a C# developer? Okay, that's pretty common for TypeScript developers. And as you probably know, TypeScript was developed by Anders Heilsberg, who is also the chief architect on C#. And so a lot of the decisions he made with C#, he repeated with TypeScript, so it looks very similar. Again, as a quick refresher, generics just mean that we can have a parameter, a type parameter that we pass to another type. So now I can have a data type that's going to accept a type parameter. So now I can determine the data type of one of the members or one of the functions at a later time. Where we see this most commonly is with collections. So while JavaScript only has an array type, TypeScript can have an array of T. If we were going to have a TypeScript implementation of the 8 queens problem, we would need a collection of queens. How many of you guys are familiar with the 8 queens problem? Okay. 8 queens problem, and it's, at least where I come from, it's a very common programming language kata, or something, a real simple problem that you solve over and over again. But the idea is that on a chessboard, you could, in theory, take 8 queens and place them all on the chessboard so that none of them can attack one another. And so if we're going to do that, we could have a collection of queens, or in this case, an array of queen. And then we could have logic that loops over each one of those queens. Now in JavaScript, we could have this same functionality, and we could put 8 of these objects into a collection. It just wouldn't be type safe. So what does that mean for us? It means that in theory, we could have a teammate or a future version of ourselves that is working on the code, and we put something into that collection that is not the type that we're expecting. So this seems like it should be obvious, but a lot of times this can really save us a lot of hassle. One of the places where my team in particular has seen the benefits of generics is actually using some of the SPA frameworks, where there's some objects that might be queen, or in some that might be an observable of queen. Or Knockout has like its own data binding wrapper around some of the data types. And so there can be these subtle programming errors where I think I'm working with a queen, but I actually have an observable queen. If I'm using TypeScript, and TypeScript is going to force me to put the right type of objects into the collection, I have some additional assurance that I'm not going to pull something out of the array and get the wrong thing. Now, one of the things that's important to remember about TypeScript is that all of our good type safety actually goes away when we compile down to JavaScript. So here's that same code rendered in JavaScript. As a part of our build system, whatever we're doing, we're going to transpile our TypeScript and it becomes JavaScript. You can see that same collection exists here on this array. And now it's just an array. It's not an array of queen, just an array. And so all that type safety that we get from TypeScript exists when we're writing the code, not necessarily when we're running the code. So that's generics. Another fairly quick refresher on how inheritance works. When we have one data type, we can have another type that inherits from it. So I can have a parent type that defines its behavior and state, and I can have a child type that adds or modifies the behavior and state. And we would say that these types have an is-a relationship. So if the concrete example here is the child type is a person and the base type is person and the child type is programmer, we could say that a programmer is a person. And in TypeScript, we can implement this fairly simply. When I define a class, I can just say that my child class extends person. This is one of the places where TypeScript is slightly different than C#, where now I'm going to use an extends keyword instead of the colon that we would use in C#. And when we build out these relationships, a lot of times the simple versions of these relationships make a lot of sense, but they can start to get messy, especially when you start to have 3 or 4 or 70 classes inherited from one another. And the is-a relationships start to get muddy, and that means that our types aren't exactly what we want. So in general, why did that circle stay there? That's strange. There it goes. What we prefer to do is have composition over inheritance. So we can build our data types up through multiple classes, not necessarily inheriting from one another. That tends to work out better. In fact, you could argue that the classic design patterns book, often known as the Gang of Four book, is just a long explanation of how we can leverage composition over inheritance. And TypeScript has some really interesting ways to use composition that a lot of the other languages don't have. So the first one that I want to talk about is intersection types. And this is the first feature that we're going to talk about today that is much more specific to TypeScript and not so much a feature of other languages. With intersection types, we can basically take two types and add them together. So let's say we're working on a piece of software that manages our software team and handles some invoicing. We could very conceivably have one class for programmer and another class for billable resource. And we could have a need to have an object that is both a programmer and a billable resource. But we don't necessarily want to say that all programmers are billable resources. And we don't necessarily want to say that all billable resources are programmers, because we can think of exceptions to both of those. So what I can do in TypeScript is I can create a new type that is like these two things mashed together. And as long as we're just dealing with the data, that's actually pretty simple to do. So in this case, I'm going to have an interface that defines a programmer employee, and it's got fields for first name, last name, and favorite language. And I've got another interface for billable resource that just defines its hourly rate. But where the real magic happens is Here what I'm going to define a billable programmer, and I'm just going to say that the billable programmer is of type programmer employee and billable resource. And all I had to do was take the two type names and use the ampersand right there to kind of join them together. And on the fly, I have created a new type that represents both of those together. And so you can see that now in this new object, I can assign a first name, a last name, a favorite language, and an hourly rate. And then I can also take my billable programmer language, or billable programmer object, and call into its first name and its hourly rate. So that works out pretty well. Now I have an object that represents the intersection of those two things. I can use it however I need. It gets a little more interesting if I have classes where there's some additional functionality. So in this version of the example, I now have a class programmer, and it's got a method getGreeting, and the billable resource class has a method getInvoiceAmount. And it's not as easy as simply assigning those two things together. Now I actually need a way to combine those methods. Well, what I can do is I can write a custom function to take all of the functions from one object and put them into another. This is a technique that is very common in the Ruby community. It's called mixins. This is not something that's nearly as common to C# developers, but TypeScript supports mixins. And so what I've got here is a function that's going to take two types, and like we talked about earlier, it's got these generic type parameters, first and second, and it is going to return an object that is a first and second, or the intersection of first and second. And it will basically loop through all of the properties on the first one and add them to the new object. And it'll loop through all of the properties of the second object and add them to the new object. And then it's just going to return the result, which takes in all the properties and methods from either object. Now this implementation is slightly naive. If both classes that got passed in, let's say they both had a method with the same name, in this case that would just get stepped on, and whichever one came in last would win. But this certainly would work. So if we were going to use this, I could define a programmer object. In this case, Don, the programmer's named Don Syme, which, for the record, I put this code example before I knew he was going to be here this week. So I don't know. It's pretty fun for me to get to walk around and have one of my programmer heroes here. So that's cool. I unfortunately won't get to see his session tomorrow because we have to travel back. That makes me sad. But anyway, back to this. We've got this object programmer. I could also just define my billable resource. There on line 5, I could call getGreeting on my programmer object. On line 10, I could call getInvoiceAmount on my billable resource. But down here on line 14, when I'm calling extend, I'm going to pass in my new programmer object with the billable resource prototype. Those mixins will get added to the new object, and now I could call getGreeting or getInvoiceAmount on that object. One of the things that's kind of cool about this is the IntelliSense on this is really good. Let's pop over to the code so you can see it. Let's see. Which, by the way, if you're keeping score at home, I'm using tsgest for all these code samples. It's just a really convenient way for me to write some TypeScript and execute it without having to be concerned with building out a whole website. So here's my object done, which I don't know if you can how well you can see that. But you can see my IntelliSense in Visual Studio Code is representing this type as the intersection type. You know, it's putting that ampersand right on there. You know, the IntelliSense is well aware that if I just have one of these Don objects, I should be able to call into any of the methods on either of the objects. So the tooling around the intersection types works really well. And that really is one of the reasons why TypeScript does some of the things it does, is to enable tools like Visual Studio Code to help you out. One of the things that a lot of people don't know is that the way Visual Studio Code gives JavaScript developers such good IntelliSense help and other tooling help is that Visual Studio Code treats all JavaScript as TypeScript. So the way Visual Studio Code does the IntelliSense for JavaScript is it just takes the JavaScript and runs it through the TypeScript compiler. And so it should not be surprising when we look at the tooling for TypeScript, and it's phenomenal. All right, so that was intersection types. The next thing that I want to introduce you to is union types. A union type is a type where we're going to say that we have an object and it is going to be either type A or type B, or type C or type D, depending on what you're doing. And so where intersection types is kind of like the logical and of two types, the union type is the logical or of two type definitions. And when we have a union type, objects that are defined as these union types can specifically only call the functionality that is common to both. But we have a way to kind of tease out the other functionality. So let's look at how we might use this a little bit. In this example, we still have a class called programmer, we have another class called tester, and we have a third class called product owner. And let's imagine that we have a scenario where we are assigning a task in our sprint to one of these individuals. But because the product owner doesn't really get tasks assigned to him or her, we are going to just limit the assignment to programmers or testers. So what I could do is I could have code that looks like this, where the assignment takes a programmer or a tester, and then I can assign the task to that person. The nice thing here is that I would actually get a compiler error if I tried to pass in a product owner. But as I mentioned before, when you're dealing with an object that is assigned the union type, you can't necessarily call the methods on one of the specific types. In this case, getName is a method on both programmer and tester, so I can call that. But getFavoriteLanguage is only a method on the programmer, and so I can't call that. That would actually be a compiler error. So when I've got one of these union types, I could substitute a programmer or a tester for that. So I declare a programmer on line 16, and I can, on line 20, assign the task to the programmer, or really assign the programmer to the task. On line 23, I could assign the tester to the task. And I don't have it here, but on line 23, if I create a new product owner and try and pass him in to the task, it will not work. Let's pop over and look at that real quick. So here's the code. I'm trying to assign a new product owner, but I'm getting a compiler error. And again, the tooltip is pretty useful. It says argument of type product owner is not assignable to parameter of type programmer or tester. And so we can know right away that, that we've done something wrong here. Now, just like we saw with generics, the type safety that we get here does go away at compile time. And so if we found some really horrendous JavaScript workaround, we could, if we could get it into the JavaScript, assign our product owner into the task. But at least at compile time, we have that type safety. And again, this is kind of the big theme of this whole talk, is that TypeScript gives you ways to help you communicate what you're trying to do to your teammates, not necessarily get additional functionality at runtime. The fact that I have specifically made the parameter to the assign method the union of programmer or tester is really for future developers, not so much for runtime safety. Now, where union types are most commonly used is to represent potential error cases. And this is a pattern that is very common if you come from a functional programming background. Developers that work a lot in Elixir or Scala or F# are very familiar to this pattern. But developers that have come from more of a C# or Java background often are unfamiliar with this pattern. So let's imagine a new scenario where we have some code that is working with these programmer objects, and in fact, it's storing them in the database. And we need to be able to retrieve some data from the database. We want to look up a programmer by name, return the result. And as you all know, looking things up in the database never goes wrong. There's no way it can ever have any exceptions, so we don't have to worry about it, right? Is that just me? Okay. You guys are probably the really good programmers. I have found a lot of ways to make this go wrong in my career. So for bad programmers like me, we need this kind of stuff. So what I want to be able to do is I want to define a class programmer that has the actual information that I want. And I want to have another class called lookupFailed. And in my code that looks up the data in the database, I am going to return a programmer lookup result, which a programmer lookup result is basically just a type alias for the union type of programmer or lookup failed. So this is something else that I'm just going to talk about real quick. Oops, that was not what I wanted. Oh, jumping ahead. So this code here on line 16, where we're going to just define a type and set it equal to two other types, that's called a type alias. This is not something that's specific to union types. You could do the same thing with intersection types. It's just a convenient way to represent what the union type is here. In my opinion, having an alias on the union type makes it even more explicit in the code what you're trying to do. It's just one more communication mechanism you have to the other teammates. So in a real version of this code, our programmer repository would have a method called getByName. They would actually connect to a database and do the SQL thing that it was going to do. In this very simple version, it is going to it's going to return a new error message every time. So it's just going to return a new lookup failed. But what we can do, because it's the union type, we can either return the programmer if everything went well, or we can return the error message. This is a contrast to how these type of scenarios are normally handled, where the return type would always be programmer, and if something goes wrong, we'd throw an exception. But when we return the union of the object and the failure, the code that calls that, it would here on line 22, is going to get back the result. And the result is going to be that union type. And instead of having to catch an exception, what I do is I inspect the result. And so I can say if result is an instance of programmer, then I do whatever the programmer thing is. If the result is a lookup failed, then I'm going to have my failure case. By the way, this is called a type guard, what you're seeing here on lines 24 and 26. The type guard is the code that looks at the actual type inside of the union type. And you could actually have additional cases if the union type supported that. But this allows us to figure out which one of the union type we actually have. One of the things that is worth noting again is that the IntelliSense on this is really good. It's actually kind of fun. Let's look at the example of that. Yeah, this is the one that I want. Nope, that was not the one that I wanted. So if I look at the type of result here, we know it's a programmer lookup result. And if I try to say result dot get favorite language, I should get a compiler error that says get favorite language does not exist on type programmer lookup result. It actually gives me an alternative solution which says get favorite language does not exist on lookup failed. Because remember, when you have union types, if there are functions that are common to all of the types, I could call those. And so I could either resolve this issue by actually only doing something that exists on programmer lookup result, or I could change lookup failed to support get favorite language, which is obviously not what I want to do. But it is worth noting that I don't have to cast the result. I just have to have this type guard. So the exact same code that is a compiler error here is absolutely fine inside of that type guard. So once I've gone through that type guard, the compiler is smart enough to know that result actually is an instance of programmer, and those methods are fair game. So, any questions so far? Yes?
Quick question. How do you decide between when to
The union types.
Yeah, so when you just throw the exception and when you say, actually, here I'll create this failure type and add it as a union.
So my experience has been that developers that start handling errors with the union types really start to enjoy that. One of the things that's nice about this is that once I've got this code, because of the way that IntelliSense works and the compiler error, you are forced to handle that error. So I couldn't call getFavoriteLanguage until I have the type guard. Once I have the type guard, then like, oh yeah, I need to handle the error as well. Whereas if an exception is thrown, there's always a chance that you just have an unhandled exception error. I'm sure you guys are all really good developers, and you'd never have unhandled exceptions in your code. Me, I need the warm hug of a compiler that forces me to deal with these things. So there's some niceties about kind of being forced into the pit of success and having to deal with those error cases. Now, the downside of that is that with exceptions, I could, in theory, allow the error to bubble up a couple levels and catch it at a higher level. And so there is some additional flexibility you get by throwing an error instead of returning a union type. So it's not that one is right and one is wrong. There's trade-offs. My experience has been that union types tend to lead towards cleaner solutions, but feel free to decide for yourself. I actually have a whole blog post exactly on that topic because this is not the first time this question has come up. My blog will be linked at the end. But if you go to humbletoolsmith.com, I have a whole blog post that actually builds out this example with both returning a union type and throwing an exception. Actually, I've got that code on my machine if you want to look at it later too. Yeah, question back here. What do you mean, can it be used in a ternary operator? I don't know. Should we try it? You guys are like, oh yeah, let's try it. What's the worst could happen? Eric will look like a moron. That's fine. So what you want to say? Favlang equals result instance of what is the that's right. Let's get rid of that. Yeah, that seems to be working. It knows that favorite language is a string. Yeah, it's picking it up. Yeah, it knows that result is a programmer by the time we get past that ternary.
But for the double quotes, if you did result dot, what does it think result is at that stage?
It knows it's a lookup failed.
Wow.
So that's actually pretty cool. Right? That was exactly how I scripted that out. Thanks, man.
I wonder what happens when you get to 3 union types.
I tell you what, you find me afterwards and we'll try it. Because now I'm really curious too. To do, see what. All right. That'll be an exercise for later. Any other questions before we move on? Yeah.
I find it interesting that they call it a union type when all you can use afterwards is the intersection.
So, I know. I should probably change that slide because I make it look like a Venn diagram and it's not really a Venn diagram, and I apologize. The visual is correct. The terminology is it's different than the Venn diagram terminology. So, I don't know. Does that answer your question? It's the terminology makes sense other than the fact that it's different than what a Venn diagram does. Yeah, question in the back.
So, what if we combine two functions? We call them, and one of them throws an unhandled exception. So, what is the behavior of that function?
So if you throw are you saying what happens if we have a function that returns a union type that could be the error, or throw an exception that could be an error? I mean, at that point, the exception, if you throw the exception, it's going to bubble out over the type guard. And so you could certainly have an unhandled exception that way. That feels like a code smell if you were both throwing exceptions and returning errors in the union type. And I'm sure there are reasons why you might do that. But if you were trying to mix those two paradigms, I think you would have to step back and think a little bit more about your design. Good question, though. Other questions? All right. So one of the other really fun features in TypeScript is something called string literals. And at first glance, they're not as thrilling as I am describing them as. But what I can do is I can create a type alias and create what kind of looks like a union of a bunch of strings. But what I can do is I can constrain objects of type grade to be one of these 5 strings. So when I do this, I can now have a method, enter grade, takes my name, and when I pass in a B, that is completely legit. But if I try and pass in an E, which is also a string, I get a compiler error because E is not in the string literal that I defined of just A, B, C, D, and F. So one of the things that often comes up when I'm explaining this feature to people is that it looks an awful lot like enumerations, which it does. But one of the things about enumerations is that under the hood, all enumerations are stored as numbers. And so while I would then have some kind of numeric representation of A, B, C, D, and F, that would be different than actually working with the string. So in this case, I could have a string coming in from various sources, and I can verify the actual string. Also, I can call these string methods on the type. And so actually having a string that's combined down to a finite set of strings can be very useful. One of the reasons this becomes a really big deal in TypeScript is that a lot of TypeScript is doing some kind of DOM manipulation, meaning that we have a lot of strings that mean very specific things. We might want to have a method that is adding elements to the DOM, but we only want it to work with divs and A tags and P tags. And so we could define a string literal that is just the union of those 3 elements. Now we actually would get good compiler time checking that the string that passed in was one of the elements that we expected. So string literals, one of those features is it's kind of sneaky in how useful it is. Usually once people start using them, they're like, oh yes, there's actually a lot of applications for that. Any questions on string literals before we move on? Yeah.
Is there a way to enumerate those string literals and also allow for operating lowercase with the same values?
So are you saying like you want to be able to define like a string literal that works with uppercase A and lowercase a? I mean, you could manually do it. But I don't think there's a way to, I don't think you can like define a type that is a case insensitive string literal. So, and also to answer your other question, I don't know of a way to, enumerate the list. There might be, I'm not sure. It's also worth noting that we have numeric literals as well. These start to get really close to enumerations. I could have a dice roll that is just 1, 2, 3, 4, 5, or 6. But again, this one isn't as interesting because enumerations do a lot of the same thing. Although one of the nice things about numeric literals is that I could use floating point numbers. So if I just wanted to have a numeric literal that could only be 3.14 or 2.71, I could define that. Oops. Oh, and it won't show me the type here because I'm never actually doing anything with it. Still mad at me. Yeah, so you can see here that type 0 is not assignable to type special numbers. So, in my use cases, the numeric literals aren't something I don't think I've ever used in production code. String literals tend to be something that gets used quite a bit. Good question, though. All right, so kind of to wrap up, to kind of put a bow on this whole thing, programming languages, like spoken languages, are communication mechanisms. One of the things I hope you have learned today is that there are some new vocabulary that you've picked up that you can use that will help you express what it is that your code is trying to do. One of the things that I do want to offer as a caveat is that in the same way that if you put all these features into like one function, it would be obnoxious. It would be very similar to meeting someone with a really large vocabulary that's really hard to understand, right? Don't go back to the office on Monday and be like, I'm going to use intersection types and union types and string literals for everything, because that's not what you want. But now that you know that these things exist, I hope that you'll see situations in the near future where like, oh, you know what I really want to be able to do here is I want to be able to communicate that this is going to be type A or type B, and I can just use a union type for that. So hopefully you picked up some new vocabulary today, and it'll help you build better, more reliable software in the future. So thanks for coming out today. Like I said, I've got a blog post up on my blog, humbletoolsmith.com, that is a little bit deeper dive into error handling. All the code we looked at today, other than the code that I literally typed in the last 10 minutes, is up on GitHub at TypeScript Beyond the Basics. All of these slides, again, except for the one I added this morning, are up on SlideShare. So if you wanted any of this information down the road, you can get it there. If you want to talk about this more, feel free to ask. I'll be hanging around for a little bit afterwards. The easiest way to find me online is on Twitter at PotterEric. I would love to talk to you more about this stuff or answer any questions you might have. So thanks for coming out. This has been fun, and have a great rest of the conference.